Hello and welcome friends in this presentation. Here I am going to discuss about the declination, its definition, the variation in the magnetic declination, how it can be used in land surveying, and we will also get introduced with the concept of depot magnetic needle. So as you learn the content, you will be able to recognize the essentiality of magnetic declination in land surveying. You will be able to explain the types of the variations in magnetic declination. Also, you will be able to explain the concept of depot magnetic needle. Mostly, as far as surveying measurements are concerned, and as we prepare the map based on this particular measurement, we refer to magnetic north direction. But that magnetic north direction is not a constant criterion. It varies from place to place over the period. There are many sites giving the details of such kind of the variation. Just for the reference, I have mentioned one here. As you refer to this, you will find very nice animations showing the variation in the magnetic north over the time. So the conclusion is it is not constant criterion. Hence, over the period, it cannot be considered as reliable reference. So, say for example, if we have some old map which is simply giving the magnetic north direction, and if we wish to continue our work in reference to that, the magnetic north that was referred on the day of survey and the magnetic north that is existing on today may not be one and same. Hence, we must know what is its location with respect to true north. Because whatever the true north, already we have defined these particular basic terminologies. So, as true north is related with the geographical north, it is constant phenomenon. But the determination of this particular true north involves astronomical observations, takes quite a time, and it is skilled yet tedious job. Instead, to determine the magnetic north is very simple. Just you have already you got introduced with the use of prismatic compass, surveyor's compass and related concepts. So here taking the bearing by making use of prismatic compass takes hardly any time. So if the magnetic declination at the time of the survey when it was done and at the time of resurvey we wish to do, magnetic bearing can be easily determined. This is the use of magnetic declination. So here on the right side map, what you see is small sketch showing the grid north, magnetic north as well as true north. So having this sketch with us, we can understand what is the flow of magnetic north direction, what is its direction, what is its magnitude, and it can be used to determine the magnetic north correctly. So, suspended magnetic needle points to magnetic north. Technically, it is not true because just we consider that particular magnetic north pole is not constant. It is moving. The needle points in the direction of the horizontal component of Earth's magnetic field at that location. The compass needle aligns itself with magnetic field line. Here, the way you see, this is the direction that is given by the magnetic needle at a place, which is essentially related with this particular magnetic north direction. Further, as we consider the lines that are flowing towards the north pole or south pole that are coinciding at the pole which is nothing but the true north pole, which is the constant direction being geographical north-south meridian. Here, for a given instant, if we consider the magnetic north direction and true north direction, the angle subtended by magnetic north direction with respect to true north direction is called as magnetic declination. In simple words, it is nothing but horizontal angle between the magnetic meridian and true meridian. So, if the north end of the compass needle is pointing towards the east of the true meridian, the declination is said to be east and treated as positive. So here, this is true north direction. With respect to that, the magnetic north is flowing towards west. Hence, this declination is said to be west declination and it is treated to be negative declination. Just two definitions of some common interest. The contour lines which are connecting the points of equal magnetic declination are called as isogonic lines. Whereas the contour lines which are connecting the points where the declination is 0 degrees, that is the magnetic north direction and the true north direction is one and same. So here as you see, for the given portion of this particular globe, here there are certain green lines which are giving the locations at which there is no difference in between magnetic north and true north. Whereas the red lines that you see, that denotes the direction of the magnetic north on the east side, as such is declination, and the blue lines that you see are showing the needle moving on the west side, thus negative declination. From this particular figure, you can easily understand that the magnetic field associated with the Earth's surface are very complex and very difficult to apply a single rule to understand the declination at a place. But having known a place, having known a magnetic bearing at a given place and the declination, we can easily have the true bearing or magnetic bearings determined over the period. The magnetic declination is found to be changing in different ways. Here, just for reference, I am presenting certain diagram showing the secular variation of the north for central Italy. Here, what you see is since 2000, or rather, let's consider the leftward figure, since 1800, this particular north is moving and attaining this field. As we consider 1600, it is moving on the leftward direction. As such, here this particular magnetic meridian swings in one direction over the period of say 100 to 150 years. It comes to rest and again it starts moving in opposite direction, as if it is pendulum. If you explore the various websites, you will find many studies associated with this secular variation. As far as our scope is concerned, we can assure that we do not have enough reasoning to understand the secular variation. Over the year, this particular variation is experienced to be 1 to 2 minutes. It is caused because of Earth's rotation about the Sun. Even the variation is found to be very small fraction to 12 minutes per day. This value varies according to the geographical location, the time of the day, as well as even season. Over the Earth's surface, as well as considering Earth as a whole and its interaction with the other heavenly bodies, the variation could be irregular, and this particular irregular variation is said to be because of magnetic disturbances. We can use this magnetic declination for the determination of true and magnetic bearings. Here, in this sketch, the blue line indicates the true north direction, which is constant phenomena. Whereas the green line AB is a line existing on the Earth's surface and hence it is also constant entity. Whereas this red line and dotted red line indicates the magnetic north. As we discussed in previous slides, it is dynamic in nature. It swings as if it is some kind of pendulum. So here, as you see, this magnetic north is lying on the left side of this particular true north. As such, declination is westward. Whereas here, what you see is magnetic north is lying on the right side of true north, hence the declination is eastward. Now, in order to determine the true bearing of that particular line, we can make use of magnetic bearing and declination. So, here as you see, if this particular dotted line is considered, the declination is eastward. Declination is eastward, hence we can add magnetic bearing and the true and the declination in order to work out the true bearing of that particular line. So sum of these particular position and these position will be nothing but true bearing. Whereas as we consider the reverse case, that is, if the declination is westward, the true bearing of that particular line will be the magnetic bearing, that is this particular total angle, and we have to deduct that particular declination which is on the westward side. Similarly, if the value of the true bearing and the declination is known, we can determine the magnetic bearing of the line. Say, here the declination is eastward. The declination is eastward. For line AB, this will be true bearing. Whereas the declination value will be this. Hence, in order to determine the magnetic bearing of the line, you have to add the declination if it is westward and negative sign if the declination is towards east. Based on the concepts that we discussed, let's attempt a few of the problems. Here, magnetic bearing of AB is given to be alpha, which is 136 degree 30 minutes. Whereas the magnetic declination is given as 6 degrees 15 minutes west. By making use of this particular data, here we can draw this particular sketch. True north is constant entity having magnetic declination 6 degree 15 minutes west. We can draw the magnetic north in dotted manner the way I have presented here. Value is 6 degree 15 minutes west. The magnetic bearing of the line is 136 degree 30 minutes. Hence, with respect to this particular magnetic north, line AB is shown making inclination of this particular alpha. Now, in order to determine the true bearing for this particular line AB, we have to deduct this theta from the total value of alpha, which comes to be 130 degrees 15 minutes. Now, in his sketch, true bearing of CD is given as 211 degrees 30 minutes. So, here with respect to this particular true north, here we can draw a line making inclination of 211 degrees 30 minutes. The magnetic declination is 6 degree 15 minute eastward. Hence, this magnetic north direction should be drawn making the inclination of 6 degree 15 minute on east side of the true north. So, in order to determine the magnetic bearing, this theta value should be deducted from alpha. As such, the value comes to be 205 degrees 15 minutes west. Here, according to the data, the old map is giving magnetic bearing of certain line as 336 degree 30 minutes. At that time, the magnetic declination was 3 degree 15 minutes west. So, for a given situation, if we consider the magnetic north, with respect to that, on the day of the survey, line AB can be shown making inclination of 336 degrees 30 minutes the way I have shown here. Now, further it is asked that as on today, the magnetic declination is 4 degree 15 minutes east, whereas on the earlier day of survey, magnetic declination was 3 degree 15 minute west. So with respect to that particular say, as this particular magnetic declination is 3 degree 15 minute west, that means the true north should be presented on the rightward side as compared to that particular magnetic north making inclination of 3 degree 15 minute. As on today, magnetic declination is 4 degree 15 minute east. That means presently this particular magnetic north should be drawn on the right side, making inclination of 4 degree 15 minute the way I have shown here. According to the earlier data, in order to determine the true bearing of the line, we must deduct this particular theta from observed magnetic bearing, which comes to be 330 degrees 15 minutes. The true bearing will be remaining same. Hence, the present mag bearing can be worked out by deducting the present declination from that 333 degrees 15 minutes, which comes to be 329 degrees. As we consider one another problem, here magnetic bearing of a line is given as 41 degrees 30 minutes, and this is in 1947. Whereas at that time the declination was found to be 6 degree 15 minute east. That means this magnetic north should be making inclination of 6 degree 15 minute on the east side, and hence the true north is presented as here. As on the current day, the magnetic bearing is expected to be determined if the magnetic north is moving 1 minute per year on the east side. As such, since 1947 till 2020, in 73 years, magnetic north will move on the rightward side, that is eastward side, by 73 minutes, which is nothing but 1 degree 13 minute. Hence, 41 degrees 30 minute minus 1 degree 13 minute, which is nothing but 40 degree 17 minute, which is the magnetic bearing of a line existing as on 2020. Here, as we try to understand the concepts behind the declination, northward movement, and accordingly the determination of magnetic bearing or true bearing, always I am referring to the sketch that I have drawn. So I would just request you all to refer the data, draw the sketch, and then you attempt the solution instead of relying on some kind of formula. This kind of the problems already you have solved, but it is just further extension of the traversing and determining the true bearings. That's why I have included this particular problem. So here already you know about the data, the lines, and how we make use of this concept in order to draw the sketch depending on that determination of included angles or exterior angles. Already you are familiar with this concept as we have discussed previously. So here, as we have worked out the included angles of the various lines, the theoretical sum tallies with the practical sum, hence there is no necessity of the correction. Further, it is found that stations C and D are free from local attraction, hence the forebearing of the DA is treated to be correct one, and the bearings of all remaining lines are determined the way we have discussed about the various problems previously. But now here there is one more additional instruction for us. What will be their true bearings if the declination is of 1 degree 30 minute west? As such, as the declination is westward by 1 degree 30 minute, magnetic north should have been placed on the west side of that particular true north. As we have to determine the true bearings, here we must deduct 1 degree 30 minute from each magnetic bearing to find its true bearing. Say for example, true bearing of AB is given as 81 degree 5 minute. Hence, so the way I have presented here, true bearing of AB comes to be 79 degrees 35 minutes. In the similar manner, all the true bearings can be worked out. Now, as we considered previously, the magnetic needle which is freely suspended will indicate magnetic north and magnetic south. Truly speaking, when it is indicating the magnetic north direction, the south pole of magnetic needle is on the magnetic north side. Hence, as we work in the northern hemisphere, the south pole of the magnetic needle will get attracted towards the magnetic north pole of the earth. Hence, the needle won't remain in the horizontal plane, but it will be making some inclination with respect to the horizontal plane. So, this downward movement of the needle is called as dip of magnetic needle. As we consider the Earth's geographical south, geographical north, and hence the axis of rotation, we can define the equator of the Earth's surface. In the similar manner, we can consider in reality the south pole and north pole of the Earth as a magnet, and the variation in the magnetic strength of that particular magnetic lines. Accordingly, here if we consider the central portion, which is nothing but the equator of the Earth's surface, the needle will be influenced with similar magnitude, and hence it will remain horizontal at the equator. Now, as we discussed previously, to maintain this particular needle in the horizontal plane is our prime requirement to determine the bearings. Hence, the way we work, accordingly, we provide some rider on the opposite side of the tip. So here the way you see, here the red portion is inclined in the downward direction. Hence, to lift it up, we place certain weight in the form of that particular rider. The way we consider isogonic lines and agonic lines earlier, for this particular dip also, we can consider the line joining points of same dip as isoclinic line, while The line joining the points having the zero deep is called as aclinic line. So I hope the concepts of declination are clear to you and you have understood how the declination can be used to correct the location, its magnetic bearing and true bearing weights. So thank you very much. In the next presentation, I will speak about use of minor equipment for angle measurement in land surveying. So bye till then, I wish you very happy learning.